Now that we've increased our capabilities in MATLAB by adding conditional statements and looping structures to our repertoire of MATLAB commands, we can start to try and solve more complicated problems. What that also means is that we're going to end up with more complicated programs that we have to write. And whenever you make something more complicated, you're ultimately going to introduce the possibility of having errors into our program. So that's what we're going to be talking about in this video, is how to identify the problems or the bugs with our programs, and also how to try and fix them. So one of the things that I've told my students is that regardless of what you get out of taking this class, so one of the most important things you can learn is how to look at a program, try and figure out what the problem is, and then how to try and solve that. Because that's applicable to programming, it's applicable to any type of engineering problem you might be facing. So hopefully it's pretty clear about why you should care about debugging, but for those of you who may not see at this point, I ask you the following question. How many of you have written a program of any amount of complexity that worked perfectly the first time you tried to run it? My guess would be not many of you could say that you have. And really, including myself, if you're writing a code that has any level of complexity, right, it's not going to work correctly the first time. It may run the first time, but it's probably not going to give you the results that you expected. Okay, so one of the most important skills that you can develop is figuring out how to identify your errors and then how to fix them. This is the process of debugging. Okay, so let's talk a little bit about the process of debugging versus the process of testing, because a lot of people tend to confuse these two concepts. Okay, so testing is taking your program and running through some sample inputs and checking to see whether there are errors in your program. Okay, so you'll have to come up with test cases or sample inputs that you know should produce a certain set of outputs to test and make sure that your program runs correctly. You'll probably have, if you were actually doing this in industry, you're going to have a whole range of test cases to make sure that you can try and cover every possible input. And the process of testing is relatively easy. Okay? You provide some inputs, you get some outputs from your program, you check to see whether the program worked correctly. That's pretty easy. Debugging is the process of, once you've found an error, trying to identify what the reason is for that error occurring, as well as trying to fix the error. So you need to go through the code, determine what portion of the code is producing the error, and then try to figure out how to correct the issue. Right? So this is going to be much more difficult than testing, because you actually have to understand how the code is working, as well as how to try and change the code to fix what the error is. Really, debugging is one of the more complicated things that you'll have to do when you're trying to get a program to work. So why is debugging so hard? Right. So the first reason is that there may not be an obvious relationship between what the error results in terms of the incorrect output or the incorrect operation of your program, and the internal causes for that error. Okay. The symptom that you see, whatever the bug is causing, and the actual cause for that bug may be in completely separate parts of the program. Right? You may have one calculation up in the first couple lines that was done incorrectly and is causing an error, but you may not see that result until you get to the very end of the program and you try to display the results. When you try to fix a bug, you may end up either introducing a new bug or simply just covering up the bug and not actually fixing it. Okay. The errors that you end up seeing may be a result of a person entering a value incorrectly or something like that, or some other kind of misunderstanding that is difficult to trace through the code. The other problem, and this is one of the crazy things that ends up happening with code, is that there may just be this one case that could possibly occur that causes your program to fail. It works correctly for every other possible case. Okay. Those kinds of errors are very difficult to reproduce, as well as to diagnose, because there's just this one case that causes the error to occur. And finally, unlike many other systems, software is a system that's running on another system, right? You have the computer, which has all kinds of systems and things going on there. You have the operating system, you have the actual physical hardware. That is all that you have to take into account, as well as what your software or your program is actually doing. Okay, so the state of the computer system may change and may cause the state of your software system to also change with unintended consequences. Okay, so these are all things that make debugging a program extremely difficult. So let's talk a little bit about how this process of testing and debugging works when you have a script that you're trying to fix. All right, so the first step is testing, right? You can't try and debug your code until you know that there's an error. Okay, so the first step is to test your program and see whether it produces an error. If it does, then you go over and you start debugging your program, trying to figure out what is causing the error. Okay, so you fix the errors. That results in you then have to test your program again to figure out, one, whether you fixed the error that you were trying to fix, and two, whether you introduced any additional errors as a result of fixing the first one. Okay. So this process continues of testing, discovering errors, and then debugging to fix the errors until your set of test cases produces no errors, at which point you can say that you've successfully then debugged your program. So MATLAB has a lot of nice features built into it to help us in this process of debugging our code. So some of them you may have been using already, some of them you may not have been, but we'll talk about each of these and see how they can help us to understand the errors that we're getting in our MATLAB scripts. So we can first try to look at the errors that MATLAB actually gives us and understand what MATLAB is trying to tell us from those errors. We can look at trying to comment out sections that are giving us problems. We can do what is called stepping through a program, which is actually putting MATLAB into debug mode, which allows us to see what is actually happening line by line as we go through our program. And then we can talk about running and checking individual sections of our code. So the one debugging technique that we've already been using, or at least hopefully you've been using, is looking at the MATLAB errors that are given to you whenever there's a problem. Okay. So there's two types of errors that we could end up with. The first type of errors are syntax errors. So that's problems with the way that you've written your code. Whether it be something like forgetting a parenthesis, using the wrong mathematical operator, so like for instance needing dot multiply instead of just multiply when you're using vectors. Right, having the wrong number of input arguments for a function, so say you wanted to use the plot command and you only give it a set of x values instead of a set of x values and a set of y values, something like that. The other type of errors are what are called logic or runtime errors. Okay, so these are errors that you wouldn't necessarily see just by looking at the code, but are produced when your program is actually running. Okay, this could be a incorrect mathematical expression. The conditions on, say, an if structure are incorrect. You might end up with infinite loops. Okay, so these are things that your program will still run, but it's not going to produce the type of results that you were expecting. So with understanding our errors, the first types of errors that we need to fix are our syntax errors, because unless we get rid of the syntax errors, your program's not going to be able to run. Luckily, MATLAB actually gives us a listing of the syntax errors so that we can go through and fix those and try to get our program running. All right, so let's take a look at some of the syntax errors that we might end up with that MATLAB will provide to us. Okay, so there's two ways that we'll see errors. The first is that if we try to run our script and it's not working, or there's a syntax error, it would give us an error message at the command prompt, right? We've seen these throughout the semester. Okay, so if we look at this error and figure out what it's trying to tell us, first it tells us where the error is occurring. So it gives us the name of the file, the line number, and then the column. The column's not usually all that helpful. Mostly the name of the file and the line number are the most helpful, as well as why that error is occurring. Okay. The nice thing about this is that if you click on the underline portion, it'll actually take you to the file and put the cursor right there on the line where the error is occurring, so you can easily try to fix the problem. The other way that you can locate syntax errors in your program is by looking on the right-hand side of your code window. So at the very top, you'll see a square. If your code is great, or there's no syntax errors, then you'll see that be green. If there are warnings, it will be orange, and if there are syntax errors, it will be red. If you look below the square along the gray border, you might see red dashes, orange dashes. Okay, those are locations where orange means that there's a warning, but more specifically, red means that there's an error. So if you hold your mouse over top of the dash, it will tell you, like you can see here on the screen, that on line 13 there is a syntax error, which in this case means that we're possibly missing a parenthesis, a square bracket, or a curly bracket. Okay, so if you click on that dash, again it will take you directly to that location in your code so you can try and fix it. Okay, so let's take a look at some of the common syntax errors we might see as a result of trying to run our program so we can know exactly what we're going to try and fix when we see them. Okay, so the first type of error you may see is kind of the generic error that MATLAB gives, which says there's an unexpected MATLAB expression. So what this means is that maybe you forgot a multiplication symbol or some type of mathematical operator between a number and a variable, so you have a variable that's starting with a number and MATLAB doesn't know what to do with that. Okay, you started a variable name, or you actually used the wrong variable name. You forgot some parentheses when you were trying to use a MATLAB function. Okay, all these different types of things will result in an unexpected MATLAB expression, which basically just means that MATLAB sees something in a line of code that it doesn't know what it's supposed to do with. Okay, this one's actually kind of easy, right? That the expression or statement is incorrect, possibly unbalanced, parentheses, curly brackets, or square brackets, right? That just means that you forgot a parenthesis or something like that. So just go through, count your parentheses, make sure you have the correct number in whatever line it specifies. All right, now that we've been using conditional structures and loop structures, right, we are now using the keyword end, right? And we need to have an end whenever we have an if or a loop. Okay, so if you forget to put the end, MATLAB will yell at you and say you're missing at least one end. That means check your if structures, check your switches, check your loops, things like that. Check to make sure that you have an end for every start of one of these different types of structures. Okay. You may also run into the situation where, let's say, you decided to name a variable end or something like that. Okay, if you try to do that, you get an error like this one. So illegal use of reserved keyword whatever, right? So whatever the keyword is that you try to use would be inside those parentheses there, or inside the quotation marks. So for instance, if you tried to type in end equals 5, because you wanted to do something 5 times, let's say, okay, it would give you this illegal use of reserved keyword end because you can't use that as a variable name. It's one of the keywords. Same thing if you tried to use if for a variable or for a variable or something like that. Pretty much any of the words that in MATLAB that show up in blue are the reserved keywords, and thus you cannot use them as a variable name. If you do, you will end up with this error. Okay, so as we said before, we have syntax errors. We also have logic errors. Okay, so most of the logic errors that we have will not be picked up by MATLAB. Okay, they're going to be problems with the output from our program, but not ones that we will necessarily be able to identify from MATLAB's standpoint. However, there are some errors that MATLAB will give us that are related to logic errors. One of which you might see, especially in a couple weeks when we start talking about arrays in more detail, is an error like this: attempted to access some variable name at some index out of bounds. Okay, so with an array or a vector, right, we've been using vectors so far. Right, you have a certain number of locations where you can store a variable or store a value. Okay, so if you try to access an index which doesn't exist, so say you have a vector with 20 values and you try to access a value at index 30, okay, there is no index 30, so you'll receive an error like this. Okay, so this usually results from, say, maybe using a loop, a for loop for instance, and having the number of iterations on your for loop be incorrect in order to deal with the vector that you're trying to access inside your for loop. Okay, so it's not a syntax error. The syntax is all correct. It's a logic error because there's a problem with how you're trying to get the code to work. Okay, you may also end up with an error like this. So undefined function something for input arguments of type something. Okay, so there's kind of two possible situations where you might see this error. The first is that you have a specific type of function, say like the square root function, sine function, plotting, things like that, a MATLAB function that you're trying to use, but you're providing it with the wrong type of data. So like providing a string to the square root or a string to the plot function. Okay. You obviously can't take the square root of the word hello. So MATLAB might give you an error saying that you're giving me the wrong type of data for me to be able to perform the operation that I want to perform. The other way you can end up with this situation is that somehow in your code you've written a statement that looks like you're trying to access a function, but there isn't actually a function that exists, either that you've created or that's available in MATLAB. Okay, so those are two possible situations where you would see this error. Okay. The other possible situation, which is kind of similar to the one we just talked about, is the error undefined function or variable x. So in this case, you've either forgotten to define your variable before you tried to use it. So one case of this might be if you have a loop control variable in a while loop and you forgot to set an initial value for that variable, you would see an error like this. Right, the other possible situation, and really you probably won't have to deal with this until next semester when we actually talk about how to write functions in MATLAB, is that if you write a function and try to use it, but you don't actually have the code file available in a location where MATLAB can find it. Okay, you would also see this because then that function would not be defined. Okay, so now that we've talked a little bit about the errors that MATLAB will give us and how to try and figure out what's causing those errors, let's talk about some of the different techniques we can use to try and fix those errors that result from things which MATLAB cannot catch for us. So one of the easiest things to use in order to try and debug your code is to comment out a line or a section of code. Okay? So we know that a comment in MATLAB is a line that's not going to be executed. So if there's a line that you know is giving you a problem, say there's a mathematical operation that isn't giving you the correct result, what you can do is just put a % in front of that line so that it won't be executed, and you can test other parts of your code to make sure that they are working correctly. Okay. The other way that you can do this is if you highlight the line and then at the top of your MATLAB window you should be able to look for a text area and then click on the comment button. It would turn it into a comment. Or if you press Control R, if you're using a Windows PC, that will also automatically take a line of code or whatever line you currently have selected and turn it into a comment by putting the % symbol automatically. Alright, so what this allows you to do is test to see whether certain lines are causing the problems that you're seeing in your code, as well as to test different versions of a specific line without having to delete them. Right, so there's a lot of times you might write a line, you don't know if it's correct or not, you want to test it, you see that it's wrong, but there may be some good components of that line that you don't want to get rid of, so just comment it out and then try and write your new line below it, so that way you haven't deleted your code and thus gotten rid of it and you can't get it back if there was something actually correct in that line of code. Okay, so you can just comment things out, and then once you get it working you can delete out those commented lines. But in the process of debugging, it's better to comment it than to delete it. One of the most powerful tools we have available through MATLAB to try and debug our code is the process of actually going into debug mode in MATLAB, which allows us to then step through a program. Okay, so what stepping through a program means is that we're actually going to execute our program one line at a time, which allows us to follow the path of execution. So let's say we have a conditional structure, it'll actually show us which section of code we're going into, so we can make sure that we're executing the correct set of code. We can also monitor the value of our variables to make sure that computations are being performed correctly and things aren't going awry somewhere in our computations. Okay, and it's really one of the most powerful techniques we have available for debugging because we can actually see how our code is being executed. And it's actually a built-in feature to MATLAB and actually to most programming environments that allow you to step through the program and see what's happening. The primary way we get into debug mode is by setting a breakpoint. Okay, so a breakpoint is essentially, it's a point in the code where you're going to force MATLAB to stop executing your code and enter the debug mode. Okay, so to create a breakpoint, you simply go to the line of code that you want to stop at. So let's say we wanted to stop at line 12. I would then left click on that little dash next to the line number. All right, and I would end up with a red dot. Okay, so that red dot is now my breakpoint. When I run my script and my code gets to that line, it will stop and allow me to then start stepping through my program. Okay, so once you've stopped at the breakpoint, you'll see this toolbar available at the top. So these are the different buttons that are going to allow us to step through our program and see what's going on. Let's talk about what some of these buttons do. So the primary one you'll be using if you're in debug mode is called step. Okay, so what this does is that it executes the current line that you're on and then moves down to the next line. We also have the continue button, which if there may be 2 or 3 lines that we wanted to test and the rest of the code was working correctly, we can step, so we could set a breakpoint right at those lines, step through those couple lines to see what's happening, and then if we hit the continue button, it will run the rest of the program, or it will run until it encounters another breakpoint. We also have the exit debug mode or quit debugging, which if we are going through the process of stepping through our program, we've identified a line that's giving us an error and we want to fix it. In order to be able to rerun your script, you have to exit debug mode. So if you click on the stop button there, it will stop debugging and you'll get back to your normal editing window. And there's a couple other buttons we have available which probably aren't as important for us right now, but they will be next semester when we talk about functions. Those are the run to cursor. So actually we could use run to cursor this semester. So once you've entered debug mode, if you want to skip over some lines, you could put your cursor on the line where you want to stop next and then click run to cursor and it would execute the rest of the code until it gets to your cursor location. The step in and the step out are the ones that I was referring to, which will be more useful next semester when we start talking about how to use functions. Okay, so step in allows us to go inside a function instead of just skipping over its execution. Step out allows us to get out of a function. So if we've written a function that we're using, we go into that function, we check to make sure a couple of the lines working, and we want to then complete execution of that function and go back to where we originally were in our code, you can use the step out. Okay, again, step in and step out we probably won't be using too much this semester. The ones that we'll really be using are probably step, continue, and exit. So once you've entered debugging mode, so you set a breakpoint, you ran your program, it stopped at your breakpoint, what you'll see on the left-hand side next to the line numbers is a green arrow. That green arrow tells you what line of code is about to be executed. So in the example down here, you can see we had a breakpoint at line 12, and our cursor, or our green arrow, is now at line 16. So what that means is that we stopped at line 12 and then we've done a couple steps and we've ultimately gotten down to line 16. So that's the line that is about to be executed. So one of the real powerful tools we have available in debug mode as we're stepping through our program is to actually watch the values of our variables that we're using. Okay, so there's a couple different ways that we can do that. The first is that if we hold our mouse over top of a variable, it will show us the value of that variable. So we can see here I have my cursor over a variable k. It says that it's a 1x1 double and the value of that variable is currently 1. Okay, so that's one of the easiest ways, is that as you're in debug mode, just hold your mouse over a variable and it will show you the value. The other way is to look at the variables in the MATLAB workspace. So this is a little bit more complicated in that you have to have both your main MATLAB window as well as your script visible at the same time. But this will show you the value of all of your variables and not just the value that you may have the mouse over. Okay. When you're using a script, which is what we've been using so far this semester and what we'll continue to use, right, all your variables remain in your workspace after you finished executing. When we get to functions next semester, the one thing you'll have to pay attention to is that those variables will only remain while you're executing the current function. So as soon as you either quit debug mode or you finish executing your program, all of your variables in your workspace will go away. Okay, so if you're trying to debug a function and you're stepping through it, just realize that your variables won't remain after you're done. You want to check the values while you're actually stepping through it. All right, so the last technique that we'll talk about is actually pulling out and checking specific sections of code. Okay, so maybe you've isolated your error to 5, 6, 7 lines that are doing some specific set of actions. Okay, what you can do is, instead of having to run your entire program every time, is to take that code, copy it and paste it into a new script file, and then just give it specific inputs and check to see whether it's giving you the correct outputs. If you do that and you identify that there are errors there, you can fix it, and then you just copy and paste that code back into your original program. Okay, this is especially useful if you have a fairly long script that you're trying to write, or if you have specific sections of your script that are supposed to be doing specific things. Okay, you can kind of build each one of those and test each one of those sections individually and then combine them to create your entire program.